Hi, today we talk about simulation 3-wire RTD use Fluke 743. RTD is very popular to detect temperature in the plant. But in the work side, if you can troubleshooting the RTD and temperature transmitter, most time we use spice to detect the temperature. But in some side, it's possible to use spice to measure temperature needs. So we use simulator. RTD is much better and fast to diagnostic is RTD and troubleshooting is temperature transmit. Okay, RTD is the just use the measure temperature. It's measure resist. If the resistor convert voltage, so if you want to do this job, you have to need exciting power. Okay, is RTD just measure resist? Okay, but he measure resist. He use the voltage, is drop voltage in the device. RTD use west bridge. Look like this. This western bridge, this RTD. This one we should know is the western bridge formulation. This resistor times this resistor equal this resistor. Oh, this resistor plus this resistor times this resistor plus this resistor equal this resistor. So we just measure here is the voltage, okay? And this is power exciting this all the circuit, okay? RTD we use 3-kind, 2-wire RTD, 3-wire RTD, 4-wire RTD. The 3-wire RTD is very popular, but 4-wire RTD is more expensive and use the label, okay? RTD is the advantage and disadvantage. RTD most measure no temperature. For example, below the 600 degree. If you're more than 800 degree, we must use the thermocouple. RTD's advantage is linear output, and its reading is very accurate. So, but its disadvantage is no sensitivity. It's vibration. Sometimes its reading is up down. Okay. But we know is RTD is very popular in the side. But RTD is still have some trouble. It's called server heating error. Server heating error. RTD have server heating error. Before we talk about RTD, he need extra exciting power, give the current to measure RTD, okay? But if you measure RTD, we should pass the electric current through the outer circuit. So he should follow this formulation. P equal current square times the resistor is a power equal current square times the resistor. This power is the dissipated power. This power just make RTD increase the temperature. It's around, it's beyond its surround environment. So if you are resistor to is increase is despite the power increase. So if the reading is increase, it's not exact. This is the environment temperature reading. In order to reduce the effect, we should have limited the current. But if you limit the current, the voltage dropped the device should be less. But if your voltage drop the voltage is reduced, the extra noisy make the voltage is high. So decreased signal voltage means we have to decrease the signal to noise ratio for any given amount of noise induced in the circuit from external source. So this when always server is RTD is trouble. It's called server heating error. Sometimes we test RTD is alarm. Is temperature too high, but we check everything. Is RTD we testing is everything is okay. Why is alarm on? That means the server heating. So if you want to reduce the server heating error, it's a better way to avoid the server heating, just diminishing the exciting current. If you want to diminish exciting current, we can use partial current. Partial current make the RTD work better. Because RTD is low sensitivity, so you can use partial current is much better. But most time nobody uses this partial current. Okay. Today we just talk is how to simulate RTD. We want to testing RTD on temperature transmitter. But if you want to use Python in the side, for example, in the code outside, it's possible to use Python to test RTD. So we can use simulation RTD to do this job and figure out the transmitter, temperature transmitter is good or not. Okay. This is Fluke 743, is where RTD simulation is wire connection. 3 wire, this 1 wire come here, is 2 wire from here to here. Okay, connection is temperature transmitter. Here, example, this temperature transmitter. This 743 communication is document, process document. This care from positive come here, connection is positive. A connection to the RTD here is negative, come here, go to the here. Okay, just follow this one. Okay, just follow this one. This one 2 wiring. Okay, connection here from 1 port, other one is other port. Okay, but if you use this one to also we use 475 to check is PV reading, and this one send the signal is the resistor to this is the 743 simulator RTD, send the signal to the temperature transmitter. Then we use 475 to check the transmitter is reading. Okay, but if you use this kind of simulation RTD, it still have a problem with the reading. Is 475 Hart 475 reading is the temperature transmit. This one is RTD's reading. Is 475 reading a little bit high. Is for 743 reading. It's about 5-degree reading. Is the reading the wiring cable from the 743 go to the temperature transmitter? Is the cable have a resistor? Is the resistor almost 1.5, 1.08, 1.05 ohm. This reading so is always higher, 5-degree higher than simulated. It has 5-degree offset. We check the RTD PT100 table. We find it's 5 degrees difference. It have 1 ohm different. So we can know this will have 5-degree offset because the cable resist. If you know this one, we can use simulation is RTD. Okay, don't worry the reading. You're just thinking about is 5-degree high, then exactly is a simulation RTD. Okay, this one is RTD PT100 table. Most time we use this table, this resistor, this temperature, but sometimes we use PT1000. PT1000 we never have a table, but how to use this table? We just remember PT1000. If you have PT1000, you just still use PT100 table. Just time 10 is the PT1000 is reading. Okay. This way, just today we talk about RTD simulation. We still add this RTD simulation is video. Okay. Measure source, choose TCRTD, choose PT100 and connect the resistor. Go to here, 75 degrees, 128.98. 1, 2, 8, point 8. Okay, enter. Yes. Yeah, it's 81 degree. I need to the high 80 degree. Maybe it's wearing have resist 80 degree. If you choose RTD, maybe
until 135 degree. We choose 151.7. 151.7. Oh, sorry. Okay. No, here's 135 should be. This one 140 degree. I need to make a high. Okay.